In these next couple of videos, we're going to talk about critical thinking and how do you evaluate information. We are exposed to a barrage of information about cannabis. We hear it from our friends, we see it on the internet, from all different sources, but how do we know if it's good information? So what critical thinking is thinking about your thinking while you're thinking in order to make your thinking better. So really it's a mindset. It's kind of a bit of skepticism mindset and a set of skills. And I'm just going to show this video to illustrate one example. So DHMO actually sounds very scary. It's involved with drownings and scaldings, and it's in poison, and they used it in the concentration camps. All these things are true. And I give this example because you can hear all sorts of things about cannabis, and you have to consider who are you hearing it from, and what is the evidence, and what is the source. And so we will consider all these things throughout the semester. We will learn to critically evaluate the information. Now, this example, I want you to read this. It's in your notes. I'm not going to go through it now. We will go through it together on Zoom. But read this and think of all the things that are wrong with it. And we will do it together as a group on Zoom. We will also talk about how do you learn about cannabis? How do you gather the information that you have? Those are two discussion questions we'll have on Zoom. All right, so let's move on to doing cannabis research. It is very hard to do cannabis research. It's harder than to do other drugs, but for my master's degree, I studied cocaine. We had pure pharmaceutical grade cocaine in the lab, and people knew we were the coke lab, and well, I'll tell the story. They knew we were the cocaine lab, and so when you walk into the lab, there are cabinets with big, heavy chains across them. But that's not where the coke was. The cocaine was in a paper bag crumpled up in a drawer with the pencils and the paper clips, because no one would look there. Everyone would assume it's behind the chains. But my point is, it's easier to get cocaine and do research on it than it is to research cannabis. So what you have to do, okay, you have to write a grant proposal, and most grants don't get funded. It's getting worse and worse. So you have to write a grant proposal that gets approved and it gets funded. And as I mentioned before, the official policy of Health and Human Services for many years, they would not fund any cannabis research that looked for benefits. They would only fund research that looked for harm. Then you have to get approval from the FDA, and you have to get a special license from the DEA, the Drug Enforcement Agency, and this is expensive to get that, and it could take years. Then you have to apply to NIDA, the National Institute of Drug Abuse, and you have to get their federally approved cannabis. You have to use the only source of cannabis. So NIDA holds the monopoly. For all legally available cannabis to do research on, it only comes from one place in the United States. That's not the case for cocaine, for anything else, just cannabis. And they don't freely give it out. So the only facility in the United States that cultivates research cannabis is the University of Mississippi. And you have to get it from there. And it's crap. It's terrible. First of all, they take it and they grind it into a powder, and that powder has stems and seeds. It's a very low potency, 8 to 10% THC, which that's not necessarily a bad thing, but it doesn't represent what people are actually using today. So if you want to get information about what cannabis does, that's not what people are using. People are using typically higher levels of THC. So it's low potency. They don't have hybrids, which again, most people are using hybrids, and it has mold in it. It has lead, it has contaminants in it, and they're not releasing information about the pesticides, about the terpenes, about any of this stuff. So it is so bad that the cannabis that you get from the government is not going to be approved. The FDA said they won't approve it for phase 3 clinical trials. So how are you supposed to test cannabis for patients to see if it helps PTSD or helps cancer if the FDA won't approve the only sample you're allowed to use because they said it's not safe enough to use, basically, because the mold and everything. So this cannabis is not approved for phase 3 clinical trials from the FDA. So FDA approval would really be impossible. There's a lot of uproar about this. So in 2016, that's 4 years ago, the government did say they would allow more universities to grow cannabis for approved scientific studies. And so you just had to apply, and it was a $34,000 non-refundable application fee. And it's 4 years later, they have not processed a single application. Forget approved. They haven't processed still any of these application fees. So number of universities, about a dozen, paid that fee, applied, and got no response. Now, different ways to do research. It's hard enough to do research, but there's different ways to do it. So let's look at the pros and cons of some of these different methods. In vitro. Officially, that means in glass. So that's going to be in a petri dish, for instance. You're going to look at the receptors. You're going to look at what cannabis binds to in receptors. You're going to look at the factors, the chemical factors in a cannabinoid. But you have to be careful about how generalizable it is. So just because something acts some way in a petri dish, that gives us important information, but does it have real world applicability? So a joint, for instance, has more tar than a cigarette does. So you might say, oh my God, it's more carcinogenic, but actually there's no increase in lung cancer in cannabis smokers in the real world. So you have to consider how it translates to the real world. Animal studies, also very valuable. This is called preclinical studies. We test things on animals first. But rats aren't people. When we get important information from them, but how much can we generalize? Mice, for instance, have serotonin receptors in different areas of the brain than humans do, and cannabis binds to serotonin. So it's an important first step, but you have to be careful on generalizability. Surveys. Surveys are very popular. I've done a few myself. And for instance, what you might do is ask people. So ask people, how much do you smoke? And there's some advantages and disadvantages. It's the only way to get some answers. You can't get people in a lab and actually, get an idea of how much they smoked or how young they were when they started. Another advantage, you can get really large samples. You can send out a survey to tens of thousands of people. They won't answer, but you can get a large population. But one of the major downfalls is people lie or they don't understand. So if you were to ask somebody, oh, how much cannabis do you use? What do you mean by cannabis? Is it CBD? That's cannabis. Is it pure THC? Are you smoking? Are you eating? How much? So people lie. You're missing out on some populations. A lot of people don't answer surveys, especially when they're about drugs. People are afraid that the government will get them for something. And so it's hard to get all the accurate information. We get some information, but it's not complete. There's also epidemiological data. And that would be, you look at a population and you look at who is using it and different things that go along with it. So for instance, people who use cannabis, are they more likely to use other drugs? You can say, oh, cannabis causes that. Epidemiologically, people who use cannabis are also more likely, let's say, to use another drug. It doesn't mean cannabis causes it. It means maybe it's that kind of person who's more likely to use any drug starts with cannabis. So we can get big ideas of what's going on, but we can't get a cause and effect situation. For that, we need a controlled experiment. Okay, so a controlled experiment, it's going to give us a lot more information. So there's, on surveys, some of the pros and cons of surveys. So surveys are easy and fairly cheap, but the cons are people lying, and you have to make sure you're not ambiguous. But controlled experiments, these are the only way to identify some cause and effect relationships. They start with a hypothesis, and what that is, it's a prediction about the world based on what you've seen. An independent variable, that is going to be what the researcher is going to change, is manipulating, is going to be controlled. And there's also a dependent variable. The dependent variable depends on the independent variable. That's going to be what you measure and observe, and that might change as a result of the independent variable. So the independent variable you think is the cause, and the dependent variable depends on that. That might be the result of your cause, of your independent variable. I'll give you an example to make more sense. Control group. That is going to be a group of participants who are not exposed to the independent variable. For instance, if you think smoking marijuana causes people to, I don't know, make their eyes water, let's just go with that, make your eyes red and water. You don't know for sure that it's the cannabis, it's the marijuana. Maybe it's just the act of smoking. So your control group then would be having them smoke, I don't know, clove cigarettes or smoke paper or smoke something else to see if is it smoking that causes the effect, or is it the cannabis that does it. And this is a way to try and control for the placebo effect, because a lot of times you're in a study or you take a drug and you assume it's going to work. Placebo effect is I'm taking this pill and I feel better, but it was a fake pill. Our minds are magnificent. They can have a lot of power, so you want to have a control group. Let me give you examples. So our hypothesis. What effect does vaping marijuana have on your perceptions of attractiveness in the opposite sex in heterosexuals? So if you're vaping, do you think people of the other sex, assuming you're heterosexual, look hotter or look not as good? So here's your hypothesis. All else being equal, vaping causes heterosexual people to rate photos of the members of the opposite sex as more attractive. So that's our hypothesis. The independent variable in this case would be, you have subjects come into the lab and they're going to vape cannabis. So our independent variable is they are vaping cannabis. Our dependent variable is how attractive do they find people. They're going to look at pictures and rate their attractiveness. The control group, well, maybe just being in a lab makes people horny. I don't know. Or maybe having smoke in the lungs or the vape in the lungs makes them find people attractive. So what the control group would be is they're vaping a substance with no cannabis in it, because your hypothesis is that cannabis does something. So your control group is going to be they're still vaping, they're still looking at pictures, but they're not vaping cannabis. So the control group basically gets a placebo. It doesn't have the cannabis in it, but some of them are going to have an effect anyway, just because they're in the lab, they believe they're getting something, they're doing something. So a clinical, controlled, randomized, double-blind trial will involve this, and that's the gold standard of research. What that is, so the clinical study, controlled, and randomized. A randomized means that the subjects represent the population. Everyone has a similar chance of being chosen to be in this study. So it's not just going to be 20-year-old college students. Your group is going to represent America, for instance. Controlled means you don't know, you may get the drug or you may get the placebo. You may vape cannabis or you may vape nothing. And double blind means that you, the participant, you don't know if you're vaping cannabis or vaping nothing, and neither do the researchers. So the researchers aren't looking at them thinking, oh, you look funny, assuming that they have cannabis. So the gold standard here is randomized, controlled, double blind. Problem? That's expensive. It's expensive to do. You need a lot of people. It takes a lot of time. And especially for cannabis. These are not easy to do, so these are difficult to perform. There's also confounding factors, one of which is something called volunteer bias. Let's say I'm calling for a research project and I want to get people in my lab to vape cannabis, and I call for volunteers. Not everyone in America is going to come to my lab to volunteer to vape cannabis. The people who are volunteering for it are more likely to be pro-cannabis. They're probably more likely to have used it, to have had a positive experience. People who have used it and had a negative experience, they don't want to come to my lab and do this. They don't like it. People who don't believe in it, they're not coming. So you're already set up with a volunteer bias of people who may be prone to give you one answer or another. Males, for instance, are more likely to volunteer for studies on sex and drugs. But drugs often act differently in the male body. So You can't necessarily generalize between what happens in a male and what happens in a female. How generalizable is this? So in research, they often use isolates. So in my vape, I'm just giving you CBD or just giving you THC, but that's not how it often works. A lot of people are going to vape or smoke flower, and it's a very different experience if you have whole flower versus if you just have CBD or just THC. Very different experience. Also, what is the dose? How much can you generalize? If I have them in my lab and they're doing 2 milligrams and at home they're doing 50, we know with cannabis you get a very different effect based on dose. Another thing to be careful on generalizability is, I'll give you an example. It's one of my favorite studies. It's called Rat Park. And what Rat Park was, it's a study of opioids. Now, we all know opioids are very addictive. And one of the ways you measure addictiveness of a drug is you get rats and you train them to press a bar. And every time they press a bar, they get a dose of the drug. Sometimes it's just injected right into them. And so rats in a cage, they learn, they press a bar and they get a dose of morphine. And these rats will just sit there all day long pretty much and get morphine, morphine, morphine. And so we say, wow, this is really addictive. They keep pushing the bar to get morphine. Well, this guy, Bruce Alexander, in late 70s said, wait a minute, rats are social creatures. And what we're doing is we're putting them in a cage alone with nothing except morphine. Of course they're going to do morphine. There's nothing else to do. So what he did is he set up Rat Park, which is heaven for rats. It's this big area with male and female rats, and there's toys and food and different supplies of water, and they can raise their young. It's this wonderful place for rats. And these rats had a choice of water with morphine or water without. And the rats in the cage push that bar all day long. And if they have a choice, they go morphine, morphine all day long. But the rats in Rat Park tried both waters. They didn't know the difference and pretty much never went back, rarely went back to morphine water. Even when he added sugar to morphine water, and rats love sweet. So they didn't want to be high because they had other things in their life. They had a partner, they had kids, they had toys, they had social time. And he went another step farther. He took the rats who were already addicted from the cages and put them in Rat Park, and they're going through withdrawal, which is unpleasant. They still chose to get off the morphine water and just interact and live their lives. And I've been talking about this for generalizability. So in a lab, if we're talking about how much somebody does a drug, it doesn't exist in a lab. You have to look in the real world. So why are people using this drug? Is it medicinally? Is it because they have nothing else? Is it because we took art and music and drama out of the schools and they need something to take them away? So we have to look at how this works, what it means in the real world. We also have to consider possible biases. So who paid for the study? Science might be objective, but scientists are not always objective. Scientists, it's publish or perish. And if you don't publish, you can literally lose your job. And it's hard to get a job as a professor these days. So maybe they're just publishing crap because they have to. And I'm just going to talk about one crap study that came out last year and everyone talked about it. And the FDA based some of their decisions based on this terrible, terrible study. Maybe you heard about it. They said that CBD is toxic to the liver. And that sounds very scary. But when you go to the primary source and read the data, all right, so what it was in mice, which fine, we start with animal studies. And 6 mice got over 100 times the maximal dose of CBD you're supposed to give. So not just the maximal dose, over 100 times the maximal dose. And they said that 75% of those mice died. They didn't die, they killed them, they sacrificed them. But think about that. What is 75% of 6 mice? That's 4.5 mice. So in their published paper, they said 4.5 mice died. All right, that's a problem. They isolated their CBD with hexane. I don't know how well they cleared the solvent. They cited other papers, and they cited them incorrectly. So they actually said the opposite findings that they did. And it was in a bad journal. It was one of those journals you had to pay to get in. I don't mean to pick, well, I do, on this one article, but the point is, why are they publishing it? Is it good science? And just because you've heard this on Fox News or you heard it on CNN, wherever, find the original data, find what it says, and analyze it so you're not just spewing the same stuff that everyone else is saying. So these are all things that you have to consider when you're a critical evaluator of information. And time-wise, I think I'll stop for now and we'll pick it up in the next video.